system whose open loop transfer function is. See, initially before we have to calculate the phase crossover frequency, we have to know what is the phase crossover frequency. Phase crossover frequency is the frequency at which phase reaches 180 degrees. That is, angle of G of S at S equals to j omega pc is equals to minus 180 degrees. So G of j omega is equals to 6 by 2 minus omega square plus j2 omega j omega plus 2. So angle of j omega is equals to minus tan inverse of omega by 2 minus tan inverse of 2 omega square. So at omega equals to omega pc, this is minus 180 degrees, omega pc by 2 omega pc 2 minus omega square pc. So if we apply tan on both sides, this is 0, tan 180 is 0, omega pc by 2 plus 2 omega pc divided by 2 minus omega square pc. So 2 omega pc 2 minus omega square pc is equals to minus omega pc by 2. This gets cancelled. Omega square pc minus 2 is equals to 4. So 6 omega pc is equals to root 6. That is, option A is correct.
This AC voltage controller controls current in a purely inductive load. If the firing angle of the SCR is alpha, what will be the conduction angle? Okay, AC voltage controller converts AC to AC. Okay, so what is the conduction angle? Conduction angle gamma is given as extinction angle minus firing angle alpha. Okay, since we have a pure inductive load, that means at pi it is going to have the extinction angle always. Okay, firing angle is given as alpha, so conduction angle gamma is pi minus alpha, which is option B.
Choose the correct statement. Option A, that is root locus method, is basically a one parameter method that is used to study the effect of varying any chosen parameter. That is correct. We can use the root locus method to study the effect of, that is total effect of varying two more parameters by doing the calculation sequentially. Yes, that is also correct. Root locus and root contours also having the property is same as the root loci. Hence all the statements given are correct regarding root locus. So option D is correct.
V is a function which is given as x square plus y square plus z square whole power minus 1 by 2, and we have to find dou square v by dou x square plus dou square v by dou y square. Now V is given as x square plus y square plus z square whole power minus 1 by 2. Let us differentiate it partially with respect to x, that is 2v by dou x, which will be half into x square plus y square plus z square whole power minus 1 by 2 minus 1 into differentiation of x square plus y square plus z square will be 2x, because we are differentiating partially with respect to x. So dou v by dou x is nothing but minus x times of x square plus y square plus z square whole power minus 3 by 2. Now as we need dou square v by dou x square, we'll differentiate it again. If we differentiate it again partially with respect to x, this will be dou square v by dou x square. Now as we have two functions, we'll use UV rule. X into differentiation of this is minus 3 by 2 into x square plus y square plus z square raised to the power of minus 3 by 2 minus 1 into differentiation of x square plus y square plus z square is nothing but 2x plus x square plus y square plus z square whole power minus 3 by 2 will be as it is into differentiation of x is 1. If we simplify, dou square v by dou x square will be x square plus y square plus z square whole power minus 5 by 2 into 2x square minus y square minus z square. Let it be some equation 1. Now similarly, if we differentiate the given function with respect to y partially twice, then the expression will be x square plus y square z square whole power minus 5 by 2. Instead of 2x square, this will become 2y square minus x square minus z square. Equation 2. Similarly, for dou square v by dou z square, it is x square plus y square plus z square whole power minus 5 by 2 into 2z square minus x square minus y square. I mean, we'll obtain these equations because they are the given function is homogeneous. Now, if we add these equations 1, 2 and 3, it will be dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. Now you can see 2x square minus x square minus x square. Similar to y square and y square, z square and 2z square. And this will be common. So the entire term will become 0. Hence the required answer is dou square v by dou x square plus dou square v by dou y square is nothing but dou square v by dou z square, which is option C. The Laplace transform of f root x, where f root x is given as certain function. We have to find the Laplace transform of this. Now, the given function is nothing but 2 by root pi times of 0 to root x integral e power minus t square dt. Now, let us first expand e power t square. I mean exponential function. It will be 1 minus t square plus t power 4 by 2 factorial minus t power 6 by 3 factorial and so on into dt. Now let us differentiate them. If we differentiate, 2 by root pi is anyway common, and differentiation of 1 is nothing but x. X is here root x, so x power 1 by 2. Similarly, the next term will be x power 3 by 2 by 3. Similarly, the next x power 5 by 2 by 5 into 2 factorial minus x power 7 by 2 by 7 into 3 factorial and so on. Now, if we apply Laplace transform to this, applying Laplace transform to this, to the above say sequence, then it will be 2 by root pi times of rho 3 by 2 by s power 3 by 2. Similarly, rho 3 by 2 by 3 into s power 5 by 2 plus rho 7 by 2 by 5 times of 2 into s power 7 by 2. If we simplify further, it will be 1 by s power 3 by 2 times of 1 minus 1 by 2 times of 1 by s plus 1 by 2 into 3 by 4 times of t by s square minus 1 by 2 3 by 4, then it will be 5 by 6 to 1 by s cube plus so on. This can be written as 1 by s cube by 2 into 1 plus 1 by s whole power 1 by 2, which is nothing but 1 by s times of root s plus 1. So the required answer is option C. And we got a fourth order method to find the approximate value of y when x is 0.2 for the differential dy by dx is equals to x plus y, and also given that x is 0 and y. At this point you have to find the fourth approximation. Now the first approximation k1 is nothing but h of x naught comma y naught, which is nothing but h times of x naught plus y naught, and we know the value of h as 0.2 and x naught plus y naught as 0 plus 1. Ultimately you will get 0.2. Now let us take h2, I mean that is k2, second approximation. It is nothing but h of f times of h by 2 x naught plus x by 2, and similarly here k1 by 2. This value will be approximately 0.24 if you simplify. Then k is nothing but 1 by 6 times of k1 plus 2k2 plus 2 k3 plus k4, and this simplification will be 0.2428, and y is nothing but 1 plus of this k is nothing but 0.2428. Approximately the answer is 1.2428, which is nothing but option A.